settle down, and we'll get started. Before I begin with today's content, I just want to check in with you guys and see how you guys are doing. Do we have any questions on stuff? We're okay. The PCA homework should be reasonable. Shouldn't be too bad, okay? And I hope it gives you an understanding of how PCA works. You know, as far as the textbook goes, PCA is in Chapter 7, and we're only just choosing the covering the first two sections, 7.1 and 7.2. The rest of Chapter 7 goes into latent variable models and kind of other stuff, but in the interest of time, we will not delve into those things. We'll just kind of cover the basics of PCA. So I hope you guys aren't too disappointed, but it's probably worth checking some of those things out. We're going to now take a step backwards and go into Chapter 6, okay? And Chapter 6 covers clustering methods, okay? So I know we've been bouncing a little bit around in the textbook, but today we're gonna begin working through clustering, okay? So this is Chapter 6. And we'll cover clustering methods, okay? So clustering is not to be confused with classification, okay? Clustering is an unsupervised method. An unsupervised learning method, which means that we are looking for structure within the data, and we're not given a goal, okay? So with clustering, we simply look for structure that exists in the data. Okay, so not to be confused with classification. Okay, in classification you explicitly have training data, okay? And in the training data, so with classification, you have training data, and the training data is labeled. Labeled with classes. Okay. And when you train your classification model, you are trying to kind of minimize some kind of classification error or something like that, right? So when we're training the classification model, okay, basically you have the quote-unquote answers. You know the class of your input data. Okay. Clustering, there's no labels. It doesn't say this is class A and this is class B. It just says here's a bunch of data. Can you identify clusters within the data, right? So with clustering data, no classes are given. Okay, you simply have data, all the points, quote, look the same. And what we're doing is we want to try to identify clusters. Okay, so PCA counts as an unsupervised learning method. You are looking for a projection that identifies structure in your data. Clustering methods also count as an unsupervised learning. So you just have your data and you're looking for structure. In this case, the structure looks like clusters. Okay, so today we will cover a very basic clustering method, and this is going to be called the k-means clustering. Okay, and with k-means clustering, what we have to do is we have to pick a k. All right, and this selection of how do we pick a k is not an easy thing to do. Okay, so picking a k is hard. Okay, this is a difficult task. Okay, but let's say we pick a k, and then and the algorithm works kind of like this. Okay, you just you have your initial assignments. Okay. Which will be random. Okay, so you just randomly assign each data point to one of the k classes. Okay, so if you have two classes, you just randomly assign each data point to one of those things. Okay. After all assignments have been made, then calculate the mean of each class, each of the k classes. Okay, the mean can be thought of as the centroid. Is that right? The centroid is the mean of something. Okay, so you calculate the mean of each of the k classes, and then from there redo your assignments. Okay, so then iterate between reassign each data point to one of the clusters based on distance to the nearest centroid. Okay. And then, after assignments, recalculate the centroid. Then you reassign each data point to the cluster based on which centroid is closest. Then you recalculate the centroid, and you just iterate back and forth, continue until assignments do not change. Okay, and that's it. Let me illustrate this with an example. Okay. So, okay, and I'm going to just put 1, 2, 3. So I will make it this very obvious, okay? So here, let's say we have k equal to 2. It's very clear that this will form one cluster and this will form another cluster, right? This is just kind of my assignment here, okay? And what we would do is we just, starting off with k equal to 2, and let me copy this. All right, so first thing is we will do our initial assignments, which will be completely random. So step 1, random initial assignments, okay? And so I just say, all right, we have 2 classes. So k equals 2, so we have 2 classes. So we will create 2 clusters. Did I write class or cluster in the last slide? I meant to write cluster in case I accidentally said class. Okay, so this point I will just randomly assign to cluster blue, and then we go to the next one, and we will say randomly, we just kind of flip a coin, and we say, is this one going to be blue or is this one going to be red? We get red. All right, maybe I flip a coin. Here, I feel uneasy about doing randoms by myself. So I'm going to just say, I'll say sample. Okay, either you're going to sample from 1 or 2. And wait, how many of these do I need? 1, 2, 3, 4. I need 4 more. And we'll do replace equals true. Huh? That's not how we do it. Did I do this in the wrong order? Okay. All right, so this one will be 1. And then the next one is 1. And the next one, I'm just going from top to bottom, is 2. And then the next one is 1. Okay, so we just randomly assign these. That's fine, okay? And then let me copy this onto our next slide so that we did random assignments, right? So here I just did, so for each data point, just randomly assign each data point to one of the two clusters. Okay, so far so good, this random assignment. Then, okay, now that I've done this, what I will do now is we will calculate the centroid of each cluster. Okay, and so the centroid is basically, what do? I'm going to, so for each cluster, we're going to get kind of a x bar, comma, like if I have, if this is x1 and this is x2, we're going to have an x bar 1 and an x bar 2. Okay, so we'll have a red mean x bar 1 and we'll have a blue x bar 1 and x bar 2. Okay, and basically each of these things will just be the sum of the xi's divided by n, right? Okay. Okay, so for red, we're going to come here and I will say, all right, what is the mean of these two data points? And it's going to be right here. Okay, so I will, what should I do? I will draw a box with a dot in it. Okay, so this is the centroid for red. Is that okay? That looks like the centroid there, right? Okay, and then I do the same thing for team blue. And what is the centroid of these 4 points? I get this. Does that look like the centroid for blue? If, sort of. Like if I have these 4 points and I have them on a piece of paper and they're all rocks, like where would the thing balance? Center of gravity? If we look only at the blue assigned points? All right, great. Well, I'm glad, thanks for laughing. All right, so then, so that's, there we go, we get our centroids. Okay. No, that's not what I want to do. I want to. All right, so now I have to really do this. This is a little bit tricky. So I'm trying to erase these assignments here. And why is this so hard? Okay. So calculate the centroid of each cluster, done. Okay, so now that we have centroids, we will reassign each data point to the cluster with the nearest centroid. Okay, so each data point we would go and say, so we'll start with this one and we say, well, that one's kind of tricky, but I would say, all right, how does this work? Tap and drag one finger to move, press 2 fingers to rotate. What? You're not helpful. I want to measure, how do I? Okay. All right, let's start off with the easy one. All right, so here's our first data point. Which one is closer? Is it blue or is it red? Okay, blue definitely looks closer than red, so we're going to assign this one to blue because the blue centroid, if we measure the distance, we can see it's closer to the blue one, right? Okay, we go to this data point and we say which centroid is closer, and this one will get assigned to blue, right? So the blue centroid is closer than the red centroid, so this gets assigned to blue. And now we have to ask which centroid is closer, and if I look, I'm gonna say the blue one is closer than the red one. You guys agree there? So we will go there, okay? And then we come over to this data point and we say which centroid is closer, and we would say, the red one is closer than the blue one. So we will assign this data point to red. And then we come to here and we say which one is closer, and although they look similar in distance, I would say the red one is closer. You know, even if it's not, it'll clear out in the next iteration, okay? And then this one is definitely, the red one is closer. Okay, and then at this point we're like pretty much done because we got the clusters correct. But, you know, I could, like, I'll show you that. Okay, so here we're done. So now that we have centroids, we just reassign each data point to the cluster with the nearest centroid. And then after that, oh man, today's lecture is going to be short. No. Okay, whoops. And then so now that we've done that, why is this not working? We recalculate the centroids. All right, and then we say, okay, what's the centroid of this one? And then we go, okay, the centroid is right here. And what is the centroid of this one? And we get this right here. Okay, recalculate the centroids. Now that we do the new assignments, okay, now that we have new assignments, we recalculate centroids, okay? And then okay, and then last step is redo assignments, okay? Okay, so technically I would have erased all of the assignments and then we redo the cluster assignments. Okay, again, assigning each data point to the cluster with the nearest centroid. Okay, and what we would see is that, yes, indeed, all three of these data points would go to the blue cluster, all three of these would go to the red cluster, and we see that none of the assignments have changed. And so we end. Okay. Does that make sense? The k-means clustering? All right. So k-means will converge to a local minimum of this quantity that we can define as d, which is kind of the total distance from each data point to their respective cluster. Okay, so here, let me just so k means clustering will minimize some measure d, or I'll say the measure d, which can be thought of as the total distance from each data point to their centroid. Okay, so for here, the d would be, I would take each data point and say, how far is it from there? How far is it from there? How far is it to there? So from each data point to their centroid, and I would come over here and I would say, how far is it from here and how far is it there? And the total length of these black lines is equal to d. So d can be thought of as how do I do this? Okay, we're going to say each data point. So if each one is a kind of a vector, so we'll say each vector x sub n to their mu sub k. All right, so xn is the nth data point written as vector in vector form, and mu sub k is the kth cluster's centroid. Okay, so we would take this, and basically the Euclidean distance would be this times itself. So x minus mu squared, but so we would do this as a transpose. Okay, and the way we add this distance only for the values is we have z and k. Z and k is 0 or 1. Okay, z and k equals 1 if x sub n belongs to cluster k, and 0 if x sub n does not belong to cluster k. Okay, so because technically if we x minus mu sub k, if we're doing it for every single data point, you know, there's technically a distance there, but we don't want to add that one. So we only add it for each x sub n that belongs to a k. Does that kind of make sense? So this is either going to be a 0 or 1. It's going to be 1 if the point belongs to that cluster, and then it doesn't for the other ones. And then you sum this up across all data points, and then you sum it across all clusters. or actually I did it backwards. You do it for all the clusters, and then you do it for all the data points. From k equals 1, and k, and things like that. Okay. And so we could see if we had, so this is the distance measure here, whereas if let me just go back. If we open up, if I copy this one, which had the wrong assignments, this is not the correct assignments. Okay, so the centroid here for red is something like, again, there's the red centroid, and here is the blue centroid, okay? The total distance is a lot messier, right? Or is a lot longer. So I would have that, and then the total distance here. You can see we've used a lot more black ink in this picture, okay? So the total D is much bigger. D is much bigger, and here is D is at a minimum. Yes?
Isn't it the same if you sum over k first and then sum over?
Yeah, it would be the same. You're right. Just trying to think if there's a place. Yeah. Okay, but yeah, you just calculate the distance from each data point to their cluster, and to decide whether it belongs to the cluster or not is this. Yes?
Will we always use the minimum?
It will always reach at least a local minimum, okay? Okay. Is that all right? So this is kind of like like a manual iteration, or at least a visual illustration of how the k-means clustering works, right? Of course, to code it up, you just have to transfer from this thought into code, but it's definitely doable. Let me talk about adding additional clusters, right? Like, how many clusters can we go for? Every time you add a cluster, this quantity D will go down, okay? And so, let me see. So if let's say I had 3 clusters, okay? Okay, and depending on the random assignment, let's see. I might get something like this. I'm just fiddling around here, okay? This might not be. This is not going to work. Okay, there. I'm trying to think. Okay, well, I'll just say, adding additional clusters will almost always result in a smaller D, okay? Because I could ultimately go to 6 clusters, right? I could have K equal to 6, and each data point would be its own cluster, and my D would equal 0, okay? I could have K equal to 6, and each data point is its own cluster, and the total D will be 0, okay? That is probably not probably. That's a bad solution. Okay, that's not ideal. That's not going to be a good. That's not going to be a good clustering. Okay, not a good solution. So, trying to pick a D, you can talk. Not trying to pick a D. You can trying to pick how many clusters can be explored through the usage of calculating that quantity D versus how many why am I not losing the word? How many clusters you have, okay? So we can try to choose a number of clusters. Choose the number of clusters by exploring the relationship between K and D. And what we will see is you will see so you start off with like K equal to 1, and 2, and 3, and 4, and 5, and 6, and you will see, a huge drop from, 1 to 2, and then as you increase additional clusters, the amount it drops will get smaller and smaller, okay? And so the spot where you have the biggest drop and then the amount of, how much you gain, kind of this elbow will kind of be a good indicator of what is a good K, right? So a good choice for K is the spot where the amount you gain is less dramatic. As you increase the number of clusters. All right. Is that okay? So increasing the number of clusters will almost always result in a reduction of D, but at a certain point, adding additional clusters is not going to improve the gains that you have in kind of reducing that total distance. Okay. Is this okay? Here, let's talk about maybe how could we code this up with pseudocode? All right, so we'll do k-means clustering. Pseudocode, all right? So we will just say X is some matrix that is n by, how many dimensions do we want? What is a letter for n by p, okay? So we have n by p, okay? And then we will have z will be a vector of length n, and this represents the cluster to which x sub n belongs. Okay, so we will start off with random assignments. So I guess you would need you'd have a function of where you have your x and then you have k, right? The number of clusters. So we'll call this k and n is a function of x and k. And what it will output, it will be the assignments of z. Okay, so the random assignments, we will just do, we're going to say z, we're going to update our z to be, we're going to sample from the vector 1 through k, and we're going to need n samples and replace equals true. Maybe I should make an assignment out of this rather than giving you the answer here. Okay, what would be the next thing we do? Okay, well, now that we have our assignments, we're going to have to calculate the centroid, right? Okay, and so we will need, maybe I will create a, centroid will be a matrix. What are the dimensions of my centroids? How many centroids will I have? I will have k centroids by and p columns, right? So basically, our centroid will be k by p. Basically, each row is going to be the coordinates of the kth centroid. So we have a total of, if we have 3 clusters, we're going to have a row of a matrix that has 3 rows in it. And let's say our data set is 2-dimensional. We have x1 and x2. It's going to be a 3 by 2 matrix, right? So we'll have 3 rows, each row being the coordinates of the centroid. Okay, so it's going to be for I in 1 through k, because we got to do this for each centroid. What we want to do is we've got to subset our matrix X based on if it belongs to class C, based on their assignment of Z, right? So we want, I'll just write subset X, so you have only the rows where the rows where Z is equal to, cluster I. Okay, So for the first one, you're going to pick the ones where z is equal to 1, then you'll do it again where z is equal to 2, and you'll do it again for z equals to 3. Okay, once you've subset that, then all you do is you find the column means, calculate the column means. Column means of the subset data. And then store those column means into your centroid matrix. Row I will be basically the column means. So if X has 2 columns of data, you'll have 2 values, 2 column means to store into the centroid. Okay, so this calculates the centroid based on the assignments in Z. Okay, and then now that we have the centroids, we have to assign each data point to the cluster of the nearest centroid. Okay, so I'm gonna have to go on to the next slide here. Is that okay? Yes, question?
Say we have 3 clusters, but none of the data points got reassigned.
Yeah. Sometimes that happens. You have maybe you calculate the centroids and then no data points gets assigned to that centroid. Basically, that cluster just dies, okay? Because there's going to be it's not going to exist anymore. Okay. Sometimes that happens. If for whatever reason no data point finds that centroid to be the closest one, then that nothing's going to get assigned to it. It's okay. All right, and then you have to go for we'll say J in 1 through N. So you have to do this now for each data point. Basically, you will calculate the distance from x sub j to each centroid. So you need, you might have to, you can do a loop inside here. You might be able to find a better way to do this, okay? Calculate the distance from that data point. Then set z. Z will equal, basically, which centroid has the min distance. Okay, so you assign the vector z accordingly, and then that's it. And then you loop over, okay? You would throw all of this, actually all of this goes inside a while loop, and then the stopping criterion, you'll need to have something that keeps track of the old z's. And you compare the old z's to the new z's, and if old z equals the new z, or new z equals the old z, then you can stop. Okay, we'll end there. If you're gonna do that, okay.